In this video, we are looking at applications involving derivatives. And so on this first type of problem, they're going to give you some facts about a function, and you're going to have to match it to a function. So I don't have the pictures here. We're just going to kind of talk about what the facts are. So on A, remember this is your x coordinate, and this is your y coordinate. So you're looking for a graph that would have the point 2, -4. So you're looking for a graph, and it has to have the point 2, -4. Okay, on B, they're telling us that the first derivative when x is equal to 2 is 0. And so if a derivative of 0, or if a derivative is 0, that means the slope of the tangent line at that point is totally horizontal. So if I'm looking at a graph and this is my x equal 2, wherever that point is, your graph would have to be totally horizontal at that point. We also call it the critical value, so it would also be a place where the graph is changing from either decreasing to increasing, so it could be coming down and then going up, or it could be changing from increasing to decreasing. So at that specific point, the first derivative would equal to 0. Okay, so on the next piece of information, they are telling me that my first derivative is greater than 0, and that is when my x value is less than 2. So if we're looking at a graph, so here's my x value of 2, and just whatever point it is on the graph. So if your first derivative is greater than 0, that means the graph is increasing up to that point. So for x is less than 2, right here, the graph would be increasing up to that point. Now, if the first derivative is less than 0, that would tell you the graph is decreasing. So that tells me that whatever graph I'm looking for the graph to be going down when my x is greater than 2. And then finally, when they tell me that a second derivative is less than 0, remember when second derivatives are less than 0, they're concave down. So of course, I would be looking for a picture that totally was concave down for all of x. So it never would have anything that is concave up. So they're going to have you match that with some different pictures. Okay, my second one is an application problem. They tell us we have a rectangular box, and it's designed to have a square base. Now, we don't know the dimensions of that square, but we'll just refer to them as x by x. And it has an open top. So it's not a cube. They do describe it as rectangular. And so in this case, what we don't know is what the height of that box is, or the length, whatever you want to call it. But we do know that the volume is to be 500 cubic inches. Now, with volume of a rectangular box, you take the area of the base. So my base was a square. It was x by x, so that area would be x squared. And you multiply it by the height of the box. That's what gives you the volume. So from that information, we get that particular equation. Now, what they're asking me about down here is, what is the minimum surface area? So when you think about surface area, you're talking about all of the sides. And don't forget, they told us that there was not a top. It had an open top. So in this case, you have the bottom, which had an area of x squared, and then you're going to have 4 sides. And the dimensions of those 4 sides, if you're looking at it from this picture, there's a side, there's a top, or not top, I've got my box sitting on its side, you could say. But anyway, there's 4 sides, and they have dimensions of x times h. So we get a formula for surface area. Now, since we have 2 equations, we can take this first equation and get our h by itself. So if I divide both sides by x squared, then my h in terms of my x would be 500 divided by x squared. And that's helpful because now we can plug that value into the second equation so that we can try to find a minimum. So my surface area is x squared plus 4 times x times the value of h, which we said is 500 divided by x squared. So if I go ahead and simplify that, I have an x squared plus 4 times 500 would give me 2,000. And when you have an x on top, but you have an x squared on bottom, you're left with just simply an x on bottom. So in order to find a minimum, we know we have to find the derivative. So I'm going to first rewrite this as x squared plus 2,000 times x to the negative first power. And that's simply because it's just easier for me to do a power rule on derivatives than to try to do the quotient rule. So now if we find the derivative of our surface area equation, we're going to get a 2x, and then we have minus a 2,000, and then x to the negative 2 power. And in order to find a minimum, we're going to set it equal to 0 to find our critical values. And at this point, I think it's easier to go back into the other notation. So we get 2x minus 2,000 over x squared is equal to 0. So if we move this term to the other side by adding it, so I'm going to add the 2,000 over x squared to both sides. So that's going to give me a 2x is equal to 2,000 divided by x squared. Now, in order to try to get the x's on the same side, we'll multiply both sides by x squared. So it cancels it here. So now I have a 2x cubed is equal to 2,000. And if I divide both sides by 2, then I have x cubed is equal to 1,000. And the way you go from an x cubed to just an x is you take the cube root of both sides. And so the cube root of 1,000 would give me 10. So 10 is my critical value. You could test it with the second derivative just to make sure it's going to give you a minimum. So, very quickly, if I go ahead and take a second derivative, you would get just so the second derivative of my surface area would give you a 2, and then you would get plus a 4,000 times x to the negative third. And so certainly if you plug that in, you plug in the 10 into that, you're going to have a positive value. And when you have a positive value, that tells us that we do have a minimum. And so the question is, what is the minimum surface area? So now if we come back to our equation here for surface area, that's just the easiest version to plug into. Our surface area is going to equal 10 squared plus the 2,000 divided by 10. So that gives me 100 plus 2,000 divided by 10 is 200. So I get a minimum surface area that is 300 square inches. Okay, on this problem, it looks a lot more complicated than it is. It's talking about a particle moving along a straight line, and the distance traveled is given by this function. And all they're asking me for is they want to know at 8 seconds, what is my velocity? Well, velocity is just a fancy way of asking about the first derivative. So if you'll first take the derivative of the function s, you get a 16t plus 27. And if they're specifically asking for the velocity of 8 seconds, you're going to plug in a t value of 8. So we would have 16 times 8 plus 27. And so 16 times 8 gives us 128. And when you add that to 27, you end up with the velocity of 155 feet per second.